Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Carolina Bays versus storms and tides. The Carolina Bays are the most prevalent geological structures of the Atlantic coastal plain, but they consist only of sand. They are fragile and easily eroded. This video uses LiDAR to examine the Atlantic coast of the United States to determine if any Carolina bays can be found at elevations of less than 4 meters above sea level, which is approximately the level reached by storm surges and tidal flooding. It is important to mention that back in 1954, Charles Wythe Cook, who had a long career in the U.S. Geological Survey, proposed that the Carolina bays were formed by eddies in the water along the coast, so the influx of water from a storm would be expected to create new Carolina bays. Just 2 years later, in 1956, Frank Melton from the School of Geology and Geophysics at the University of Oklahoma wrote a rebuttal to Cook's paper in which he concluded that the gyroscopic theories proposed by Cook failed to predict the aspect ratios of the bays, their orientations, and the creation of overlapping bays. In addition, Melton found that no elliptical basins or rims are found beneath the water surface at any place. The elliptical bays are not present on the floodplains of modern rivers in the Carolina coastal plain, nor are they being formed by modern rivers or estuaries anywhere. The basic conclusion from Professor Melton's research was that water destroys rather than creates the bays, and this is what we would expect from incursion of water from a storm surge. The National Hurricane Center defines a storm surge as an abnormal rise of water generated by a storm over and above the predicted astronomical tides. This rise in water level can cause extreme flooding in coastal areas, particularly when a storm surge coincides with a normal high tide, resulting in storm tides reaching 20 feet or 6 meters in some cases. Hurricane Katrina in 2005 had storm surges of 25 to 28 feet, which is 8.5 meters. In addition to storm surges and astronomical tides, heavy rainfall can erode the Carolina bays. Hurricane Florence was a powerful and long-lived hurricane that caused catastrophic damage in the Carolinas in September 2018. Torrential rain flooded the landscape. This image shows a farm field with a multitude of water plumes dragging sand toward lower elevation. The flow of water on the surface can completely obliterate the sandy structures of the Carolina bays. This image shows a portion of the eastern part of North Carolina near the Virginia border. The Pamlico Terrace at an elevation of 7 meters above sea level has many Carolina bays, but the Princess Anne Terrace at 4 meters above sea level does not have any bays at all. The Pamlico Terrace has an estimated age of 100 to 500,000 years, and the Princess Anne Terrace has an estimated age of 40 to 80,000 years. The logical conclusion seems to be that at one time all the surface in this image was covered with Carolina bays prior to 100,000 years ago, but when the sea level increased and covered the Princess Anne Terrace 40 to 80,000 years ago, all the bays in this terrace were eroded. This can be interpreted to mean that the Carolina bays are more than 100,000 years old, and therefore they cannot be associated with the Younger Dryas impact 12,900 years ago. However, since the Princess Anne Terrace is at an elevation of 4 meters above sea level, it is also possible to consider that the bays were created 12,900 years ago at the onset of the Younger Dryas cataclysm, but that the bays in the lower terrain were washed away by flooding from storm surges and storm tides during the last 12,000 years. A terrace that is at only 4 meters above sea level can easily be flooded by storm surges, many of which exceed 6 meters. The National Oceanic and Atmospheric Administration keeps historical hurricane tracking data. This image shows the paths of hurricanes in North America during the past 150 years. The United States is constantly battered by hurricanes. As indicated here, Georgia and the Carolinas show the largest concentration of hurricane landfalls along the Atlantic coast. Even if only 2 hurricanes per year made landfall in the Atlantic seashore, in a period of 12,000 years, there would be a total of 24,000 hurricanes, many of which could have produced storm surges capable of destroying Carolina bays in terrain below 4 meters above sea level. Therefore, it is worthwhile to examine the LiDAR images along the east coast of the United States to see if there are any Carolina bays at or below 4 meters above sea level. A report published by the U.S. Geological Survey in 2013 indicated that the southern Chesapeake Bay region is experiencing land subsidence and rising water levels due to global sea level rise and extensive groundwater pumping in the region. The topographic image on the right shows the decrease in groundwater levels around the pumping sites in the towns of West Point and Franklin, Virginia. This accounts for subsidence of 1.5 to 3.7 millimeters per year, which is more than half of the observed land subsidence in the region. Glacial isostatic adjustment is thought to contribute to land subsidence in the southern Chesapeake Bay region. In other words, the land is sinking. This image of the tip of the Delmarva Peninsula in the Chesapeake Bay region has no Carolina bays in the terrain that is at 4 meters above sea level. All the bays are in the terrain that is 10 meters above sea level. Moving northward along the tip of the Delmarva Peninsula, we find some ghostly bays that are about to disappear at 2 meters above sea level. Barrier islands protect these low-lying bays from the open Atlantic Ocean. It is remarkable that the terrain with higher elevation at 4 meters above sea level does not have any Carolina bays, when the lower terrain at 2 meters above sea level still conserves the outlines of the bays. This can only be explained by land subsidence, which causes this region to have the highest rate of sea level rise on the Atlantic coast of the United States. Land subsidence can take some bays from higher level to a lower level, which means that some bays found at 2 meters above sea level could have been originally at a higher elevation. The USGS report on land subsidence says that the mid-Atlantic region is moving slowly downward in response to melting of the Laurentide ice sheet that covered Canada and the northern United States during the last ice age. When the ice sheet still existed, the weight of the ice pushed the underlying Earth's crust downward, and in response, areas away from the ice sheet were forced upward, forming a glacial forebulge. The southern Chesapeake Bay region is in the glacial forebulge area that was forced upward by the Laurentide ice sheet. The ice sheet started melting about 18,000 years ago and took many thousands of years to disappear entirely. As the Laurentide ice sheet melted and its weight was removed, glacial forebulge areas, which previously had been forced upward, began sinking and continue to sink today. This movement of the Earth's crust in response to ice loading or melting is called glacial isostatic adjustment. Data from GPS measurements and carbon dating of marsh sediments indicate that the regional land subsidence in response to glacial isostatic adjustment in the southern Chesapeake Bay region may have a current rate of about 1 millimeter per year. The area in the estuary of the Neuse River in North Carolina does not have bays even in terrain that is 12 meters above sea level. This area is frequently buffeted by ferocious hurricanes with very high storm surges. The estuary of the Cape Fear River in North Carolina does not have any Carolina bays at coastal elevations below 7 meters. This is consistent with the idea that storm surges of 7 meters or 23 feet can destroy the sandy structures of the Carolina bays. The Atlantic coastline by Charleston, South Carolina, does not have any Carolina bays at elevations lower than 12 meters. The coast is completely exposed to the powerful hurricanes in the Atlantic Ocean. Continuing south along the Atlantic coast, we see that the area south of Savannah, Georgia, does not have any Carolina bays below 12 meters above sea level. The storm surges from hurricanes are probably the destructive forces that wash away the Carolina bays in this portion of the coast. A paper published in 2017 proposes that the Carolina bays originated 12,900 years ago from secondary impacts of glacier ice ejected by an extraterrestrial impact on the Laurentide ice sheet. At that time, the sea level was 70 meters lower than today, and sea level rise has covered and destroyed the Carolina bays that were in previous coastlines that are now submerged in the Atlantic Ocean. The east coast of the United States is a major target of hurricanes that developed in the Atlantic Ocean. In addition to sea level rise, storm surges and the heavy rains associated with hurricanes are powerful erosive forces that destroy Carolina bays along the coast. The only Carolina bays found below 4 meters above sea level are in the Delmarva Peninsula, which is undergoing the fastest rate of subsidence in the Atlantic coast. I would like to thank Chris Cottrell from Dabbler's Den for reminding me to consider subsidence in the Chesapeake Bay area. In the battle between the Carolina bays versus storms and tides, it is evident that the storms are winning. Slowly but surely, the Carolina bays will be destroyed by the persistent and powerful effect of water erosion. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.